Hey, I wanted to talk a little bit more about nohup, what that an ampersand means in commands, and then we're going to review bash, and we're going to apply some of those bash things to a nice little script that I want to write in class today. So I just want to talk really quick about nohup. Again, remember, when your terminal closes, if you have backgrounded jobs, you have things that you had left running in the background, those will be closed. So let's just, I'll do the same nclp 8888, that, then you would control Z and then could BG it. It will remain running in the background. PS AUXF. We can see we got our netcat running right there. If we exit our terminal, we test again, there's no netcat running anymore. Or actually it is. What the fuck? Oh, that's interesting. Didn't expect that to happen. I don't know why that happened. Starting this lecture off very good, I see. Okay, so let's try it this way. If I do an ampersand, it'll run in the background. Let's see if it's still running. Yeah, I have no idea what I'm talking about. So anyway, yeah, right. So normally when you do something like this, I did it. The funny thing is, I did it on Monday, at least the Control Z BG, and when I exited the terminal, it stopped. But I don't know what's going on right now. So if you do this in ampersand, it will be sent to the background right away. Now the only thing about doing that in ampersand is you'll get a lot of the output from the command actually right out into the terminal, even when you're still running things and working on things. So let's say I did something like let's say I did like what's something tail. I'll make a file here really quick. Tail f file, not fail, tail f file, and we'll ampersand that. It'll go into the background, and then I could echo. Let's just put ASDF into that file. See, even though that command's still running in the background, all of its output is still outputted to the terminal. But no input from the terminal actually goes to it. So that's one of the kind of annoying things. Let's say we're running something in the background here. What we might want to do is redirect its standard output to like dev null. So I will just kill all tail really quick and run this again. But instead this time what we would do is redirect to dev null. So now, okay, that makes sense. Now, when I echo things to the file, and normally that would be outputting things out, and it'd be just cluttering up my terminal in the background. That's not happening anymore. So some programs also have something called standard error. So let's say we do a curl. So we just curl ASDF. Now I'll go over to the other terminal because it'll take a little bit more room. Curl ASDF.com. So that will just take the HTML of that web page that I put in, and it will write it straight out to the terminal. Let's say I wanted to redirect that to a file. I could just say asdf.html or something. Sorry, you can't see it. I'm typing it down here. I'll do it again. So it's redirecting our standard output from that command into that file, but we're actually still getting this standard error output. So this is outputted to standard error. It's when programs output things to standard error, it's usually for information. It's not for data. One of the reasons we have to have both standard out and standard error on the Unix system is because everything's based as a file, and very often you'll pipe the standard out from one file to the standard, or from one command to the standard in of the next command. And you'd have no way of seeing if things were actually succeeding or failing if you weren't putting things to standard error, standard error. So we could actually redirect the standard error as well. I believe, if I remember correctly, we can say to, and then we could say asdf.error. So So now we can see we got no output from the terminal, but we should have two files now. So we have a asdf.html, which is just the HTML, and then we have the asdf.error. And there we have that. So that's kind of interesting, I guess. So you'll have to do those kind of things if you're running things in the background in this manner. We're going to talk, hopefully, coming up soon, how we could actually run things in the background more efficiently. But I want to get into some other things before we get into that. So just remember, of course, you got your single bracket thing to redirect standard out. So standard out from this command to this file. And then if you also wanted to redirect standard error, you'd say to, and then the file you want to put that standard error to. So it's pretty straightforward, I think. So background, no hup. So if this demo was going correctly, hup would have been sent to that process and it would have died when our terminal exited. So let's say you had a process that was dying when it received hup, and you didn't want it to die, you wanted it to continue in the background. There's actually a command that will catch that hup signal for you. You can just say no hup, and then whatever command you were running. So even though this, I think maybe netcat catches hup by default. That's probably a reasonable explanation, but let's say it didn't. We could say no hup nclp 8888. And what it'll do is it'll send it to the background instantly, and it will automatically detach it from our terminal. So it's no longer controlled by this. It will never receive that hup when our terminal exits. So it says ignoring input and appending output to nohup.out. So that means by default, let's say I did try and connect to it. So normally when I would connect to that netcat, it would show the output in our terminal. So I say nc localhost 8888. I send it as what? Oh, because it took one thing and then it died instantly. Oh, well, that's kind of whatever. Anyway, you have a command that you want to run in the background. You run it with nohup. Automatically removes it from this terminal tree. Reparents it under a init so it won't die when your terminal exits. It'll automatically handle all of that input things, output things. So just use that when you're backgrounding things from your terminal, basically. All right. So the big thing that I wanted to do today was kind of review Bash. Now, hopefully you remember most of the stuff from operating environments, but there are a couple things that I wanted to cover that are kind of interesting. So again, didn't really cover this in much detail before. I'm just going to delete a couple files here for my sanity. Okay, so we want to make a bash script. So first thing you need is, let's just call it script.sh. So you don't necessarily need the shebang up at the top. So again, what this does is it instructs, when we're processing this shell, what program to run it with. So when we have an executable script, so remember you need your script to be executable, script.sh. When you have that executable script, it will look at the very top of the program, and this is the command it will run, and all further lines or directives inside this file will be run with that interpreter. So you could do something instead like bin sh. So sh and bash actually have slightly different features, kind of minuscule. Or you could do something like Python, and if you had a Python script that actually be user bin or env or whatever. And then all the further commands inside that file would be interpreted as Python commands. You could do things like Perl too if you wanted to. You could probably even do something like JavaScript, which would be terrible. But for now, let's just keep with it and do our bash. So remember, we have a couple very straightforward things. To declare a variable, you say, let's just call it my var, and then equals whatever you want it to equal. So let's just call it data. To use that variable somewhere, you would just say echo $, and then your than your variable. So you would substitute this variable right here for this value right here. So we got data. Let's say we wanted to do it multiple times. You can actually stack your variables right next to each other if you wanted to. Not something I specifically recommend doing, but it will actually find those variables anywhere. So you could do something more specific like this. You could have like a string. So you could say, my var is my var. And actually search through that string. It would find that $sign variable name inside that string, and it would replace it. So let's your basic variable. Let's say you wanted to capture some data from a command that you're running. Let's say you run hostname-i. We talked about that one on Monday. It gives you your IP address. So let's say you just wanted to get your IP address. You could say dollar left parenthesis and then hostname I. That would capture just the standard output again and store it in IP. You could say echo my IP is IP. And there you got your IP address. That's pretty neat. So the other way of capturing things, so one thing that if you actually spend a lot of time in a bash environment that you'll come to see very quickly is there's a million different ways to do everything, which turns out to be really annoying if you're reading other people's stuff. So one way to capture commands was, the output from commands was this way, and this is kind of the way that I prefer. But there's also another way you can use, where is that here? You can use tildes instead to capture your output, or backticks as they'd be called in a Unix environment. So this should work exactly the same way. And there we go. So we got capturing commands, we got variables. Let's do ourselves a quick little for loop. So let's say we wanted to do something with all of the files that are currently in our directory. So we could say for file in ls, so that will capture the output from ls, and then we could do this for loop. Done. So just as a really simple example, I'll echo file. So for every iteration, every item inside of ls, we will declare this variable file, and then we'll have that variable accessible to us inside this block here. So we have two files right now. Again, we could do something like lsa, and that would show us all of our files. So that is really nice. Let's say we wanted to do something like we could echo our file name. Let's say we'll give it some stars, asterisks to kind of show it off, and then we'll say cat file. This is going to be car. And I need to do cat, not car. So we can just see, in addition to showing off our files, we have each one with a nice little header. So this is just a super simple example, but we get onto it more later. So let's do something else. Let's say we wanted to print the absolute path of all of our files. So we could say d equals pwd. So pwd, what that will do is print our working directory, so it'll print where we're at right now. So what we could do is something like, let's just take this down a little bit. We could say echo d file. And that would be a nice little script to get, And that would be a nice little script to get the absolute file path of all of our files right now. So let's say we wanted to, what's a good test here? Let's say we needed to test if script exists in our current directory. We could say if, we'd say -f script.sh, then, is it then, or is it? It's the syntax is a little weird. We could say echo script exists. Script exists. So this -f inside of this if statement would test if this file exists, and then it will execute this block inside here. So I'm going to talk a little bit more about this test right here. We could actually use that directly on our command line to test things. We could say fscript.sh, and that will set this return value. If we tested something else that didn't exist, and then test that again, it would set a different value. So if we wanted to do a one-off command that would just do this right on the command line, we could type it in all in one line. We could say this, double an ampersand, and then echo yes, or echo no. My quotations are a little bit off there. Echo yes, echo no. So the ampersands, if this is true, then this will be executed. Otherwise, if it's false, then this will be executed. Let's say we only wanted to execute something if it was false. We could just say this, echo no. Let's say if we wanted to create the file if it didn't exist, we could do something like this. So we're going to test if it exists, and if it doesn't, then we could say touch script.sh. And again, touch just makes that command, or makes that file. But since it already exists, it wouldn't do anything. Let's say we could do something like this. We could say if it does exist, we could move it. So basically rename it script.sh, my.sh. I'm just going to close this over here really quick. And we can see that file was moved. Well, I guess you can't. Yeah, you can. You can see that file was moved to the my.sh file. So, there's a number of different things you can do to test files. Remember, everything on a Unix system is generally represented as a file. Sometimes we're going through some interesting files that we want to test if something is a link, test if something's a device, test if something's a folder. There's just a number of different things that we could substitute in here that we could use to test for any number of those different things. Yeah. Let me see what I had here. Okay. So essentially what I wanted to complete today was I wanted to look at like an if config or something like that. I wanted to parse out a number of different information points using a bash script. So bash has all of these kind of language built-in things that we can use, but in order to actually parse our information, we're probably going to want to use a number of other different commands. So the two commands that we're going to use to do that are tr and cut. So tr, it's pretty straightforward, translate or delete characters. So this is useful when things are a little bit weird, and I'll show what that can be used for. And then there's cut, and we'll talk about that. So I'm just going to make a little bit of data here. I'll just say data, and I'll just say 1, 2, 3, 4, 1, 2, 3, 4 ASDF, something like that. And that's our data. So let's say we wanted to get these O's right here. Let's say we had something interesting right there that we wanted to get. We could cat that data, and then pipe it into cut. So when we're working with cut, we have to specify the delimiter. So what is between the data? So I'd say D, and then I'd say space. So there's a space in between each field, and then I have to say which field I wanted, and I wanted to get field 4. So that would give me my O's right there. Let's say I wanted to get a different field. I could say 1, and that would be 1, 2, 3, 4. So pretty straightforward, I think. The only thing you do have to do is recognize when there's other types of delimitors. So sometimes data might be separated by a tab. So with that, you would have to use the /tab instead. It's supposed to work. I've tested it. Oh, it uses tab by default. That's right. Okay. So you can just F1, F2, F3, F4, and so on and so forth. So let's say we wanted to take and store one of those things inside a variable. Remember, we could just do this. D equals, and capture the resulting output from that command, and then echo D. Oh. So that's pretty neat. So that's cut. Just F and D are the main things that you want to look at. So the other thing that's worth looking at is TR. So by default, let's look at our data here again. So I could say cat data, and let's say I wanted to replace all the occurrences of A with B or something like that. I could just say TR A B, and that would, at least in standard output, show us this A had been changed to a B. Let's say I wanted to delete all occurrences of A. I could say TRD A, and that would delete that A. So kind of interesting. The other thing we could do is, let's say we have something that has tabs right now. So this is delimited by tabs. Let's say we wanted to instead delimitate that with spaces. We could change our tab to a space instead. So that's cool. So yeah. Okay, so the other final thing, there's this TRS, which is squeeze. So it will take any number of the characters specified, and it will replace it with one character. So occasionally you'll have something that's, let's say, delimited by 5 spaces, or maybe some random number of spaces. If it's weird padding and things like that, you could actually take an arbitrary number of spaces that's delimiting something and squeeze it down to 1 space. And then you could continue on to cut F1D space, and then work on it from there. So let's do this. So what I wanted to try and do here was, let's try and parse out this ifconfig block. So we've got a number of different lines here that we're going to need to look at, and it's probably not going to be very easy, unfortunately. So later we're going to get on to how would we parse this out in an easier way, but we're going to do it, of course, the hard way to start out with. So let's go ahead. Let's keep this open. Let's keep it open over here approximately, so we can keep track of what's going on. So let's just go ahead and say let's just see what happens when we do this. So we'll say for line in ifconfig, do echo line. So that's kind of interesting behavior. So let's look at exactly why this is happening first and foremost. So we can see that things are being split a little bit weirdly here. We can see that in addition to being split on these spaces, it's actually being split on new lines as well, which is kind of curious. One of the things that we can do to control where that data is being split is actually set this variable called IFS. So I think IFS stands for file separator, intermediate file separator, something like that. By default, when you pass something into this like a for loop, it will split the data on any white space. So it would split on space, would split on tab, would split on new line, split on all sorts of different things. So let's say we wanted to just split on space. We could say something like that. So IFS to that. And now we only ended up splitting on space. So this is kind of an interesting output here. Let's try something else. Let's try and run that on just new line and see what happens. It's because my terminal is small, I think. My escapes aren't working right. So normally this should give me a actual literal new line, but it's giving me an N for some reason right now, and I can't figure out why. Okay, we're going to do a bit more simple example. We're going to have to just cover some different things because matching this stuff is just super annoying right now. Let's try and parse our PS output. So instead of doing this, we would say PS, and again, let's just echo line right away. Again, we're going to have the same issue here since we're going to break on everything. So I'm still going to need to figure out how to set IFS to new line. Oh, and that time it worked fine. Okay. So now we're successfully splitting on new line. Let's do this. We'll say if line equals PID, I want to find starts with. Okay, here. Well, okay. Changing my mind again. Sorry. Let's say for item in line. We'll do this again. Unfortunately, we'll have to change our IFS back again, I think. Let's do space. Do done. We'll just test that out really quick. Okay, this is more closely what I want. Yeah. Okay. So now let's say we wanted to do this. We could do something like test if our first item is PID. We might want to strip off that header. So the two ways we could actually do this two different ways to strip off that header in PS. We could say PS, and then we could actually say use like tail or something to get a number of lines prior to that. But for now, I'll just actually test if item equals PID. What I want to do is try and return or something. Unfortunately, I had to break, and I had to break again. Break out of the outer for loop, which is tricky, unfortunately. This is painful. I'll try and find out how to do it with head, because that would be a better way to do it. Tail and -1. Okay, so this isn't going to actually work right. We have to write a bigger thing to figure out all of this stuff. But just for right now, I'm going to just get this output here. So we're just going to change this up a little bit here. So PS, then we're going to get the last four lines there. Should be N4. And echo item. So let's do this instead. So instead of doing the second, okay, this is where I got off. Instead of doing the second for loop, let's do a cut instead. So let's say PID equals cut echo line cut F1D space echo PID. Say PID is, and then we could go on to the next field. Just say TTY, go to field 2, and let's say we just wanted to create an output with just those components. So we could just say my.sh there. So 28. That's interesting output. Go line, cut F1D. I'm never echoing anything else though, which is weird. Oh, that's why, because my delimiter isn't actually working. It is kind of working. Ugh. So this is the kind of position you get yourself into when you're doing all of this bash stuff. Things kind of work and things kind of don't work. Things work on certain platforms and don't work on other platforms when you go to test them. Oh, and it's just all sorts of fun. And you're getting slightly minutely different output every single time here. Go line P. So why in the world is that happening? F1D line PS. I think it's still because my IFS isn't working quite right. So, well, I don't know what we're going to do about that. Let's try another example, I guess. Let's find something else to look at. Here's what we'll do. We'll go find some logs or something to look at. So let's say we wanted to do something like, we'll not even do a script for this, we'll just do it straight in the terminal. Let's say we wanted to get all of the usernames from this file here. So this is the auth log. So this is a log of everyone who's logged in or logged out on this computer. So you can see it's pretty straightforward. We have month space, day space, time space, user. So let's say we wanted to get only the users. We could say cut F, what are we at, 3, we'll just run it and see what happens, and then eliminate on spaces, and then we'll say auth log. So we didn't get quite far enough there. We got times, let's say we want to do F4, that would give us all of our users. Really quick, I'm just going to go over to root. I'll try to run that again. Don't have anything new. Well, let's take that. Let's say we wanted to get a list of all like unique usernames on a system. So in order to take that, we could say pipe that into sort, pipe that into unique. So that would sort everything. In order to actually get unique things, you need to sort it first. And we can see there's only been one user that's actually logged on. So yeah, particularly a good example. See if there's anything else around here that I could look at. No. That doesn't do me much good. Okay. So, final feature I want to talk about with Bash. Unfortunately, I'm bouncing all over the place here. So what I'm probably going to talk about on Friday is regular expressions. Probably should have talked about that first. Knowing all of that stuff would have made all of this easy. And in my mind, that's where I'm going first when I'm looking at all of these things. I'm trying to think of how I would do this with a regular expression, because most of these things are very suitable for doing regular expression type things. The final thing that's worth talking about is functions. So we talked about a little bit about this before when we were trapping on Monday. Function, we just say function name, and then brackets, and then like echo ASDF cat. It's echo 1, 2, 3, 4. To call that function whenever we wanted to, we could just say fun. And there we go, we got our function. Another interesting thing to do with Bash is argument parsing. So you could say echo number or $1. When we ran my.sh and provided an argument in the first position, it would allow us to use those arguments in our program. So if we wanted to get the first argument, we could say $1. If we wanted to get the second argument, we could say $2. So let's say we wanted to test our arguments there. We could probably do something like if $1 equals like an empty string. Hopefully that will work. We could say echo, you need to set $, or we can't say, we have to escape the $, so it's not interpreted, and then fee, and then exit right away. So it would tell us that we needed to set our first argument. We could test and see if arguments have been set. ASDF, okay. So let's say we wanted to execute a certain number of commands on a certain argument. Instead, we could say if $1 equals echo yes. Let's say we could just say just say yes. So then I could say my.sh, echo yes, and we could ye, but not yes. because I mistyped that. So we can go through and we could test all of our different arguments. The other interesting thing to do is sometimes we want to just write a wrapper script that just wraps around another command and just passes certain things into that command. We can actually get all of our arguments by saying $at. So I could just echo $at. And when I run my.sh, I could say ASDF1234, and we would have all of those all in one variable. So you notice how I just passed it to another command there. If we were just wrapping around something else, we could do that. Instead of doing something like echo 1, 2, 3, 4. Just a little bit more succinct. What else do we have here? I think that's about all I wanted to do for that. So, let's talk a little bit about what we're going to do on Friday. So, part of this that was so hard, let's talk about why this was kind of a hard problem to solve and why I wasn't really thinking much when I decided to do this one. So we have kind of a mix of like white space. We have different delimiters, so we have a colon there. We have a number of spaces here. We have probably a tab here, new lines, and then a bunch of different things. And it's just kind of hard to match all of this all at once. So when we're writing a regular expression, what we can do is we could say we want to match this component right here, and then we'll match this component right here. We'll store this particular component into a variable, and we'll discard this component. So regular expressions are pretty powerful, especially in the Unix environment. We'll look at commands like grep, which will search for a regular expression. We'll look at commands like sed, which will replace, delete, or duplicate, or do any number of different things. Sed is very, very powerful with regular expressions, hopefully coming up. So just to give a little intro to that, what I might have done is done something like grep. I need to do egrep for regular expressions, and then I could have done something like start at the very beginning if there is an alphanumeric character, so A through Z, right at the very beginning, we would print that line. And then I could pass that into tr squeeze, and then I could do something like cut d delimited on space field 1, and then we have all of our interface names. So super, super complicated. Way more complicated than it should be, but the only alternative to doing that is to go and write a C program which retrieves all of the information, which also is no fun. Okay, I remembered one more thing that I wanted to cover, and that was looking at the proc file system. So let's go look at our own PID inside the proc file system. Remember, inside proc is information about our processes. We can put our PID in there. LSL CWD. We can see where our current process is executing. We can see what actual binary it's executing. We can see we're executing bash, obviously. We can see what the root directory is, things like that. There's also something interesting. It is, where is it? Command line. So this one's a little bit harder, actually. Let's do that nclp 8888 again. And then psocks. Find that netcat, that's this process. So we go into the process tree there, and we cat command line. So it's actually really kind of odd, and it's not really something that we can interpret. So what's actually happening here is this is shoot. So this command line inside this proc directory is actually null delimited. So if you remember in C, you'd usually end a string with that, like that /0, that null. Well, this particular file actually, instead of being delimited by spaces or something, is actually null delimited. So we can actually take that, put it through tr, and then we should be able to say a null and change that into a space so it's more parsable. So instead of our nulls there, our /0s being there, we'll have spaces, and we could actually look at each individual part of that command too. So if you want to get more information about things that you see in PS, like what the entire command line is, normally if you ran PS, I guess you do see it here. On particular systems, they might not have the functionalities to show you the entire command line, so you might need to look for it a little bit more in depth. If you want to go into a bash script and you want to automate any of this stuff, you could come into this directory and actually see a number of different things. What the actual executable is, what the command line is, where it's currently running. Those are all kind of interesting things to know. So I will stop this horrible train wreck again. This is just a week of train wrecks for me, I guess. But I promise I have good content on regular expressions. That's something I'm particularly good at in my mind. So hopefully we'll find something very good to do for that. And then we'll come back to all these problems again and actually solve them in a way that's intelligent and not terrible. So that's all I have for you today.